So let's plot one full period then of y equals 2 sine of x. Okay, does anybody remember what happens to it? Let me write a generic function up here. So suppose you know what the graph of y equals f of x looks like. Remember, when you plot a graph, a lot of people forget, when you plot y equals f of x, you're actually plotting input values, which are x, and output values, which are y. But y is f of x. So the graph of a function y equals f of x is all the ordered pairs, such that you get x, you get an input of x, we'll represent it by x for the first coordinate, and an output of f of x. Y is f of x, right? That's what the function notation is telling you. It's telling you what y is, and then you have to realize the input is actually going to be the first coordinate of your points that you plot. And so another notation is for a function would be the set of ordered pairs x comma f of x. Anyway, does anybody remember, if you've taken, say, college algebra, what happens if I take the original formula for f of x and I change it so that the output is 2 times f of x? What is that? How does that affect the original graph of y equals f of x? It stretches it by a factor of 2, right? So points that were above the x-axis will be twice as far. So in the original graph, points that were above the x-axis will be twice as far from the x-axis as they were before. Same below, right? They'll get stretched down twice as far. So in this case, then, we can expect an amplitude of 2. But guess what? Remember how I promised I'd show you a shortcut? We're not going to plot points. You don't need to do that here. Sometimes there's no choice. You have to plot points. And we have calculators that plot points way faster than you ever could. But for trig functions, there's an easy way. You just remember what the sine wave looks like, and you plot that, and then scale it appropriately. So I remember what one period of the sine wave looks like. It looks like this. I'm going to graph it, and then I'm going to scale it appropriately. Okay, the period won't change. We didn't mess with the input of x at all, so the period will still be 2 pi. So notice what I did. I drew the graph first, and now I'm going to scale it. The period's 2 pi. And then this middle point right here will still be pi, where the middle x-intercept is. And then where this peak is right here, it'll still be half of pi over 2. And where this minimum height is at that point, it'll still be halfway between pi and 2 pi, which is 3 pi over 2. Now what changes is the amplitude. So what will I label that hash mark on the y-axis? I'll label it 2, and then this one? -2. -2. There you go. We're done. That's way faster than plotting points, isn't it? Draw the graph first, because you know what it looks like, or if you don't, you will. You'll draw it off enough that you will. And then scale it appropriately. Now the period will change. In the next problem, the period will change, but the method won't. I'll draw the graph and I'll scale it appropriately to the new period.